Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. At the end of the video, we'll go over the common reason why you should buy the car that has a better miles per gallon. Alright, so this is a US customary / English unit question. So it is imperial. Alright. So a driver owns a Ford Taurus which consumes 651 gallons of gasoline per year when driven 12,001 miles. If the driver switches to a Ford Explorer, the annual gasoline consumption increases to 851 gallons. Burning 1 gallon of gasoline produces 19.8 pounds of carbon dioxide into the atmosphere. Calculate the additional amount of carbon dioxide emissions by the driver responsible over 5 years when they make the vehicle change. Step 1, you can draw your free body diagram, your FBD. In this case, it's your vehicle and the exhaust coming out will be the carbon dioxide. Alright, so the FBD in this case doesn't matter too much, but it's always a good idea to draw a free body diagram. Step 2, list all the given variables, find the unknown. So 651 gallons for the Taurus, Explorer is 851 gallons. Carbon dioxide per gallon is 19.8, so 19.8 pound mass, LBM, per gallon. And then number of years driven, which is 5 years. Step 3, find the formula for the extra carbon dioxide produced. So that is the extra amount of gasoline multiplied by the carbon dioxide emitted per gallon. They give us half of the equation. They give us the CO2 emission, which is 19.8 pound mass per gallon. So we need to find the other half, which is the extra gallons of gasoline used. So step 4, find the formula for the extra gasoline used. So that is the difference in gasoline per year multiplied by 5 years. So they give us the 5 years. The difference, we can work that out. So step 5, we can find the extra gasoline. So 851 minus 651 gallons multiplied by 5 years. That's 1,000 gallons of extra gasoline used. Okay. So step 6, now we can find the extra carbon dioxide emitted or produced. So it is the extra gallons of gasoline used multiplied by the carbon emission. So the 1,000 gallons is what we just worked out, and they give us the 19.8 pound mass per gallon. Multiply those together, you get 19,800 pound mass of carbon dioxide released into the atmosphere. Okay, so that concludes the thermodynamic side. Now for a pro tip in buying cars, or I should say explaining the reason, you should always buy a car with the best fuel efficiency. 1, you'll save on fuel. 2, you will save on releasing carbon dioxide, as this calculation has shown. So we can just quickly go through. So this is just bonus stuff in case you actually buy a car. I know most viewers are university students, so you're probably catching a bus or subway or train or something. So I guess when you get into your engineering job, you can afford a car. Alright, so first of all, we want to work out our average miles per gallon. So what you do is miles driven divided by gallons used, and that's how you get your MPG, miles per gallon. So as you can see, the more fuel efficient one gives you more mileage, so it gives you more distance traveled for the lower amount of gasoline used. In the States, they call it gasoline. Over here, well, I guess everyone else calls it petrol or petroleum. Okay, so Taurus has the more fuel efficient vehicle, and the Explorer uses more fuel and less miles. Alright, so as stated, Taurus is more fuel efficient. The Explorer consumes more fuel per mile, leading to higher emissions. Alright, so there is a direct correlation between fuel efficiency and carbon dioxide emissions. So if you use the lower fuel efficiency, so fewer miles per gallon, MPG. So if you use the Explorer, you will emit more carbon dioxide because you are using more fuel. So carbon dioxide is proportional to the amount of fuel burned. Every extra gallon of fuel adds 19.8 pounds of carbon dioxide to the atmosphere. So this means choosing your vehicle that is more fuel efficient reduces your carbon footprint over time. And then, of course, we've got our discussion note. Choose the car that uses the more fuel efficient amount to reduce greenhouse gases. So I guess the notes say this. However, this extra stuff, this was just a bonus tip in case you are buying a car. So this is not in your lectures or slides. This is just, I guess, a tip for buying a car. It seems like common sense, but this is just the math behind why you should buy a car that's fuel efficient. Okay, so disclaimers. The method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things happen. If you're on a Mac, use the Mac equivalent of snipping tool. If you never used snipping tool before, follow these instructions. Click on the icon in your taskbar. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program. Once open, click on video option, click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish. Hit the red square in snipping tool to stop recording and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. Also, let them know on the math behind why they should buy a fuel efficient car. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.